Okay, so in this video, we're going to do a quick review of the laws of supply and demand. This is the foundation of so much of what we do in health economics, and it's important to make sure we're all solid on the basics before we move on to more complex applications. So I'm just bringing it all back to this review of the laws of supply and demand. Okay, so the law of demand says that all else equal, which is ceteris paribus, when the price of a good falls, people buy more of it. And when the price rises, they buy less. So it's that simple. But remember, this only holds if we assume everything else, like income preferences or the price of substitutes rather, stays constant, right? And again, this staying constant of all other factors is what economists means when they say ceteris paribus. So here we're looking at what's called the demand schedule. It's just a table that shows how much of a good people are willing to buy at different prices, right? So for example, at 60 cents per apple, people, or maybe in this case like society or the grocery store, are only, but we'll say people only want 300 apples, right? But as the price falls, so it falls from 60 cents to 50 cents per apples, we see that the demand for apples increases to 450. So as the price falls, the quantity demand rises as well. At 20 cents, we see that the demand rises to 800, and at 10 cents per apple, we see the demand rises all the way up to 1,000. So if we take the points from the table or the demand schedule on the last slide and plot them on the graph with price on the vertical axis and quantity on the horizontal, we get the demand curve. And as expected, it slopes downwards. That means at lower prices, so for instance 10 cents, we get a higher quantity demanded. So the demand curve is just a graphical way of representing the relationship we saw in the table, that as price decreases, quantity demanded increases. Now, let's talk what happens when the price of apples changes, okay? So in this example, the price goes up from 20 cents, so here we are, 20 cents to 50 cents, right? At 20 cents, people wanted 800 apples. At 50 cents, they only wanted 450 apples, okay? So that drop from 800 to 450, this is what we call a change in the quantity demanded. Notice that this doesn't evoke a new demand curve. Demand itself, the curve itself hasn't shifted. Instead, we're just moving along the same demand curve from one point to another. So the key takeaway here is the only thing that causes a change in quantity demanded is a change in the price of the good itself, nothing else. All other factors will shift the demand curve, but the price change with the price change, we only move along the demand curve. Okay, now let's switch from demand to supply. So this graph shows the supply curve, which tells us how much producers are willing to supply at different prices, right? On the horizontal axis, we've got quantity supplied, and on the vertical axis, we have the price. So the law of supply says that there's a positive relationship, right? The law of supply says there's a positive relationship here, okay? As the price of a good goes up, producers are more willing to supply more of it. Why? Well, because higher prices means higher potential profits. So unlike the demand curve, which slopes downwards, the supply curve slopes upwards. And that upward slope captures this basic idea. At higher prices, right here, higher prices motivate producers to bring more goods to the market, right? So at higher prices, we see more goods supplied than at lower prices. So we're back here to the same kind of schedule, only this time we have a supply schedule here, right? And this is just showing us what happens to the supply of apples as the price per apple decreases, right? And it's the complete inversion of the demand schedule. So here we have our highest price of 60 cents, and we can see the quantity of apples supplied is 700, right? But as we move down by 10 cents, so if we go from 60 cents to 50 cents, the quantity of apples demanded goes down to the quantity of apples supplied goes down to 650, right? We know from the demand point of view, more apples will be demanded because the price per apple is decreased. But from a supplier's point of view, when the price is decreased, their potential profits decrease as well. So then they're less willing to supply that original amount. So we go all the way down to 10 cents per apple, and we see that suppliers are only willing to supply 200 apples at this price. So this is like an inversion. This supply schedule is an inversion of the demand schedule. So when we plot those points that we just looked at in the supply schedule on the graph, with prices on the vertical axis and the quantity supplied on the horizontal axis, we get the supply curve. And just like the law of supply predicts, the curve slopes upward, reflecting that higher prices encourage greater production. So here's an important distinction. When the price of a good changes, we don't shift the supply curve. We simply move along it, right? So in this example, the price of apples rises from 20 cents to 50 cents, okay? At 20 cents, producers are only willing to supply 300 apples, right? But when the price for those apples rises to 50 cents, suppliers increase to 650 apples, right? So that movement from one point of the curve to another is called the change in the quantity supplied. And the key takeaway is that the only thing that causes a change in quantity supplied is a change in the price of the good itself. If something else changes, like technology, input costs, weather conditions, anything like that, that's not a movement on the along the curve. That would be a shift in the entire supply curve, which we'll see a little later. But a change in price for the good results in a shift along the supply curve. So let's bring supply and demand together. This table shows what happens at different prices for apples. So at high prices, say 60 cents per apple, suppliers want to sell a lot, but consumers don't want to buy as much, right? Because sellers could make a lot of money, but consumers would lose money. So that in this kind of condition, right? So we see at 60 cents, we have the quantity demanded is 300, and the quantity that suppliers would supply is 700, and this would result in a surplus, right? A surplus of apples. When there's a surplus, prices face downward pressure because sellers want to get rid of their excess stock, right? So they're going to decrease the prices for their apples. Now, at low prices, say at 10 cents, right, per apple, consumers want to buy a ton of apples, right? 1,000 apples. But suppliers don't want to produce that much because they're only making 10 cents per apple. And this creates a shortage, right? And shortages put upward pressure on prices because buyers are competing for too few goods. So the only place where quantity demanded equals quantity supplied is here at 40 cents. And that's our equilibrium, right? So at equilibrium, there's no pressure for prices to rise or to fall because the market has balanced itself. The quantity demanded at this price of 40 cents equals the quantity supplied at that price per apple. So here's how markets naturally move towards equilibrium, okay? So here at 60 cents per apple, producers right, are eager to sell 700 apples, right? So let's see, we've got the price here is 60 cents. And to see how much producers want to supply at that price, we look at the supply curve, right? And so at 60 cents, producers are wanting to produce or wanting to sell 700 apples. But at this price, consumers, right, only want to buy 300 apples, right? Because we look what's going on with consumers on the demand curve. So that creates a surplus of 400 apples, 700 minus 300, right? So here, so that would be evoked here in this entire part of the graph here is the surplus, right? So with too many apples left over, sellers then will sell at lower prices. And as the price drops, two things happen at once. Suppliers reduce the number of apples they're willing to sell, and consumers buy more, right? So you can see movement along the demand curve, which is the red line here, towards the higher quantity demanded, right? As the price is decreasing, consumers are going to move along the demand curve and demand more apples. So eventually this process stops at the equilibrium price at 40 cents, right? Where quantity demanded and quantity supplied are both 550, right? Because this is the intersection of the supply and the demand curve. So at that point, there's no surplus or shortage, so the market has found its balance. Now, let's look at the supply side of this adjustment. As prices fall, it's not just consumers who respond, producers do too, right? When the price drops from 60 cents to 50 cents, say, some apple growers decide it's not worth to bring as many apples to market, right? Maybe the lower price won't even cover their costs, so they reduce their supply. And we can see this as movement along the supply curve, right? So at 50 cents, instead, the apple suppliers will supply 700 apples. Is that right? Oh, I'm sorry. No. At 60 cents, the apple suppliers will supply 700 apples. But then if this price decreases to 50 cents, it seems that suppliers then will only supply about 650 apples, right? So at the same time that consumers are demanding more apples because of the lower price, producers are pulling back and supplying fewer apples, right? And both of these movements along the demand curve and along the supply curve push the market towards equilibrium, right? We're all getting pushed to here. So what we've been describing is like a back and forth process between buyers and sellers, and this process continues until the market discovers the equilibrium price. So in this example, that equilibrium happens at 40 cents per apple. And at this price, the quantity demanded is 550 apples, and the quantity supplied is 550 apples. And that matches up perfectly. So there's no surplus at this price, and there's no shortage, and therefore there's no pressure for prices to change further. This is also a good place to emphasize the signaling role of prices, right? Prices aren't just numbers, they're messages. A lower price signals buyers to purchase more and tells sellers to pull back production. And a higher price does the opposite. It signals buyers to cut back and tells sellers to bring more to market, right? So the equilibrium price is essentially the point where these signals balance and the market clears. It's called the market clearing price. So up to now, we've looked at equilibrium as if markets always move there smoothly and with perfect precision, but in reality, markets rarely behave that neatly. Instead, they often overshoot, right? Prices may drop too fast or rise too quickly, and this can lead to temporary shortages, surpluses, and even full-blown panics, right? A good example is toilet paper during the kind of first arc of the COVID-19 pandemic. So at the start, there was a sudden spike in demand for toilet paper that completely overwhelmed supply, and prices jumped way up for toilet paper. And even when supply chains adjusted to the increased demand for toilet paper, you can see here on this graph here, you can see here that the price stayed elevated for months, right? So this shows how markets sometimes wobble around equilibrium rather than immediately settling into it, right? The takeaway here is that equilibrium is a powerful concept, but in real life, markets can be messy and unpredictable before they stabilize. Okay, so here it's just a reminder to be very precise with your language when you're talking economics, because small differences in phrasing actually mean very different things. So a change in quantity demanded means movement along the demand curve. A change in quantity demanded means movement along the demand curve. And it's always triggered by a change in the goods price. So for example, if apples drop from 50 cents to 20 cents, people buying more apples, sorry, I'm getting too excited about supply and demand laws. For example, if the price of apples drops from 50 cents to 20 cents, people buy more apples, right? And that's just moving along the curve. A change in demand, on the other hand, means the entire demand curve shifts left or right. And this happens not because of a mere price change. It happens because of factors other than price. So things like changes in income, preferences, the sizes of populations, so things that are external to the price of the good. So even though we sometimes casually say the curve shifts up or down, what's really happening is a shift to the left or to the right, okay? And the same exact distinction applies on the supply side. A change in the quantity supplied is a movement along the curve, while a change in supply means the whole curve shifts. Okay, so we know now that a change in demand means the entire demand curve shift. So let's look at what actually causes a shift in the demand curve. So the first thing that could shift a demand curve is changes in tastes and preferences of consumers. So when something comes into style, people buy more at the same price, and the demand curve shifts to the right, right? So for example, when Taylor Swift wore an outfit from Hill House on Instagram, demand spiked instantly and the product sold out within hours. Right? So before Taylor Swift wore this outfit, Hill House wasn't in the spotlight, and they kind of experienced just sort of normal demand for their products. And then this big celebrity wore an outfit from their collection, and all of a sudden they had a shock to demand, this incredible increase in demand. That would cause a shift in the demand curve, okay? Second thing that would cause a shift in the demand curve is changes in income or wealth, right? If people suddenly have more disposable income, they're able to buy more goods even at the same price. So a recent example would have been when President Biden had the student loan forgiveness proposal, and it went through, and students spent more on other things like retail and repairs because effectively they had more money available to them, right? So that's an example of a change in wealth and income that would shift the demand curve. So finally, changes in expectations, in consumer expectations, would shift the demand curve to the right or to the left. So if people think prices are going to rise, like during COVID when used cars prices were surging, they buy more now to avoid paying more later, right? I think this also happens all the time when like a new iPhone is going to come out. The expectation is that the future iPhone will be more expensive, so maybe older versions are bought up more, or maybe less, because there is the expectation that a new iPhone is coming. So consumers halt their buying of the current version of the iPhone. If people expect their income, to increase, maybe they got a new job that starts off in a couple of months or something like that. They may feel more comfortable spending more money today, right? So think of an AI expert who sees reports that salaries in their field are about to double, right? They're more likely to go out and spend. The key takeaway is that all of these factors shift the entire demand curve and don't just move along it. Remember, moving along the demand curve is a change in price of a good. A shift in the demand curve is a change in all of these other things. Two more big factors that can shift demand are the prices of substitutes and the number or composition of buyers. So first, the price of substitutes. Substitutes are products that can replace one another, right? So Coke or Pepsi, for instance, or Coke and Mr. Pibb, these kinds of things. So if the price of Celsius energy drink goes up, but Monster energy drink doesn't raise their prices, people buy fewer Celsius drinks, okay? That's just movement along Celsius's demand curve. But at the same time, demand for Monster rises, and that would shift Monster's entire demand curve to the right? So one product's price can directly affect the demand curve for its competitors. Second, the number or composition of buyers in the market will affect the position of the demand curve. So if more people suddenly want or allowed to buy a product, overall demand increases, right? Imagine if the legal driving age were lowered to 15. Overnight, the total demand for cars would rise because more people are eligible buyers, right? So in short, substitutes and the size of the buyer pool are also powerful forces that shift the whole demand curve, and they don't just provoke moving along the demand curve. Okay, so another important distinction in the in demand and shifts in the demand curve is the distinction between normal goods and inferior goods. So for normal goods, demand increases when income increases and decreases when income falls. That is the marker of a normal good. Apples are a normal good. Think about eating at restaurants or buying high-end clothes, right? So when people have more money, they tend to spend more on those things. But with inferior goods, it's the opposite, right? Demand for them actually goes down as income rises. A classic example is store brand groceries versus name brand groceries, right? If someone gets a raise, they may switch from buying crispy rice to Rice Krispies. But if their income drops, they might go back to crispy rice, which is the cheaper brand, right? So crispy rice in this case is the normal good, and Rice Krispies is actually the luxury good. So the key takeaway is that income affects goods differently. Normal goods move with income, and inferior goods move against income. And whenever we think about income changes, like when we look at when we looked at demand shifts earlier in this presentation, we need to remember that inferior goods will behave in the reverse way. Okay, let's look at the supply side now. So just like the demand, supply can shift because of outside factors. The first is changes in the price of inputs. Now, inputs are things like wages for workers or fuel or raw materials. If the cost of inputs goes up, producing each unit becomes less profitable. So firms will supply less of the good. The second is changes in the technology of production, right? So if technology improves, say a new machine makes production faster and cheaper, the cost per unit goes down. And that makes it more profitable to produce, so firms will supply more, okay? And finally, changes in worker productivity can also shift supply. So if workers become more productive, then production costs per unit falls, right? Maybe workers receive training or get university degrees and become more productive. This means higher profits and more supply when worker productivity increases. And here again, we're holding everything else constant, ceteris paribus. So we're assuming that productivity gains don't automatically lead to higher wages. That would offset the benefit, right? Because then more of the supplier's inputs would go towards wages of the more productive employees, right? So we're ceteris paribus. We're not thinking about that. So overall, anything that changes the cost or efficiency of production will shift the supply curve either to the left or to the right. Okay, so let's talk about how to actually put everything we've learned together and into practice, okay? So whenever you're faced with a supply and demand problem, the very first step is to sketch out this diagram, right? So the first step is to put price on the vertical axis and the quantity on the horizontal axis. Then you should draw your demand curve as the downward sloping line. And this shows that as price goes down, quantity goes up. Label that one always as D1. Then next, always draw your supply curve, right? And that's always the upward sloping line, which shows that as price goes up, producers are willing to sell more. Always label this as S1. So this is the original supply curve and the original demand curve, which is what the 1 denotes. So next, map out or indicate the point where the two lines cross, right? And this is your equilibrium. So this gives you P star star, the equilibrium price, and Q star star, the equilibrium quantity. Okay, good. So this is where we are now before anything happens, right? So next, this is where you start your analysis. So once you have this sort of framework in front of you, this is where you start your analysis. So anytime you're asked about shifts or changes, always begin with the equilibrium point, right? And then think about what causes the curves to move. So remember, it's much easier to start with the baseline equilibrium before moving the curves around, right? So always sketch out this diagram as your starting point and then perform your analysis. So now that we know how to sketch out demand and supply, the next step is applying it to real world shocks. So a market shock is just something that suddenly changes conditions, like a bad harvest or new technology or change in consumer tastes, right? So let's go through this. So first thing you want to do is you want to ask, will this shock that I'm being presented with affect demand or supply? So for example, if consumers just suddenly decide apples are the new superfood, that's demand, right? But if a frost kills half the apple crop, that's supply, right? So think like this is the shock, this is the curve that it's going to affect, right? So next, decide, does it make demand or supply increase or decrease, right? That tells you whether the curves shift to the right or to the left. So next, you want to sketch the new curve on your graph. If it's the demand curve, you draw a new demand curve shifted over, right? So we'd either shift it up if demand is increased, or to the right if demand is increased, or down to the left if demand is decreased. If it's supply, same thing. Draw a new supply curve that is shifted in position to the old or the original supply curve. And then you want to find your new equilibrium price, right? Your new P star star and new Q star star, right? That's how you analyze where the market will settle after the shock. Okay, so let's put everything together with a concrete example. Suppose new research comes out that shows that drinking beer actually helps you lose weight. This sounds fantastical, but let's just imagine that this happens, okay? The research is published and it changes consumer preferences. Suddenly beer looks a lot more attractive. Okay, so in this case, what happens? So let's think through this. So all of a sudden, consumers have a new interest in beer. So this would be an example of consumer preferences and tastes changing, and changing in a way that they want more beer. So the demand for beer would increase, right? So we see then that the demand for beer would shift to the right? And we'd go from D1, the demand curve D1, to this demand curve D2. So notice this isn't just a movement along the curve, right? Nothing happened to beer's price yet. This is a shift because consumer preferences have changed. So now look at the graph. At the original P star here, demand has increased and people want more beer. So to meet the higher demand, suppliers raise their price to P star star up here, right? And we get P star star because this is where the original supply curve intersects with the new demand curve. So at that higher price, we see that quantity supplied also increases, right? We go from this price to this price, and even at that higher price, because there was a demand curve shift, there is a higher quantity supplied, even at a higher price. So we show that as movement along the supply curve, right? Nothing has happened to shift the supply curve yet, right? It's just a change in price of beer because the demand increased, and that's just a shift along the supply curve, right? So the market then will find a new equilibrium with Q star star here, with more beer being bought. Now, this is in the so I mentioned in the last slide something about the short term. I'm just making a note because this will become more relevant later. This immediate shift in the demand and then the resulting change of price is in the short term. Over time, so the short run is what we say in economics. Over time, the supply and demand curves will readjust, and we will get a new price and quantity that is probably, it'll be like a new price that is probably lower than P star star but higher than P star, and a new quantity that could be anything at this point, but that would be the long run anyways. So just know these terms, long run and short run. Okay, so let's look at a second example here. So what happens when wine, a substitute of beer, becomes much cheaper? So people can switch between the two, wine and beer, depending on price, right? If the price of wine falls, demand for wine goes up, right? A movement along the demand curve. That means some consumers who might have bought beer now switch over to wine instead. And as a result, the demand for beer decreases. So on the graph, you can see this demand curve for beer shifting leftward from D1 to D2, okay? So this is a totally new example. The study about beer making you lose weight never came out in this example. So this is a shift in the entire demand curve, not just movement along it, right? Because something external, the price of a substitute wine has changed, right? Because this is the demand for beer. So when demand for beer falls, the equilibrium price for beer drops from P star to P star star, and the equilibrium quantity of beer sold also falls from Q star to Q star star. Now, notice that the supply curve doesn't move here. Suppliers are still willing to sell beer at the same set of prices, but the lower demand means they move down along the supply curve to smaller quantity supplied, right? So this example illustrates how changes in the price of related goods, like substitutes or complements, can shift demand curves and lead to new equilibrium prices and quantities. Okay, so that's it. Just overall, demand and supply analysis always comes down to the same logic, right? Prices adjust as buyers and sellers respond, moving markets towards a new equilibrium, right? Whether it's change in like consumer tastes or preferences, incomes, or the price of substitutes, what matters here is recognizing what shifts, okay? Demand, supply, or just a movement along the curve. And then what you need to be able to is trace how how that shifts, how that shift like leads to a new price and quantity. So thank you very much. See you in the next video.